Everyone, welcome to Broadband Deployment News. I'm Rick Husey with Zcorum. So there's a technology called free space optical that could help resolve some of the challenges in BEAD deployments, especially some point-to-point, maybe middle mile or backhaul kinds of situations. Help speed the deployments up and maybe reduce the cost, make things get deployed a little bit faster. Can take a look at an article. Be right back. Hey, Rick Husey with Zcorum. Thanks for joining me for Broadband Deployment News. I want to take a look at this article and comment on it and look at a few other things as well. So you see here, free space optical could hop over railroads with fiber-like speeds. This was in Fierce Network, and it's not just railroads, but there are some challenges when deploying broadband. Of course, you've got last mile deployments, which a lot of people focus on is getting the broadband, to the subscriber, but you've also got to get broadband to the area where you're going to have those subscribers, which is one of the challenges. That's why we've got the middle mile program as part of the Infrastructure Act, and this can help. So you see here, this is specifically talking about a company called X-Lumin. X-Lumin wants to support middle mile networks as well as backhaul, tower to tower, and tower to data center deployments. Free space optical uses the same laser light beams as fiber optic cables. The technology can bring fiber-like speeds to places that are difficult to span with fiber, and the free space optical company X-Lumin wants to get the word out to all the ISPs deploying fiber. So I'm helping to do that right now by kind of giving them a little bit of plug, but I'm also going to plug something similar that Google is doing, I guess Alphabet, through their what do they call it, Moonshot program, X. Let's read through this a little bit. So is it still fiber broadband if it doesn't include the optical glass or the cable coating surrounding the glass? No, it's not, because fiber optics is the fiber. X-Lumin, a company that does free space optical technology, says the answer is yes. Well, I wouldn't call it fiber. I would call it laser optics, maybe, not fiber optics, because there's no fiber. And the company thinks it has something special to offer operators deploying fiber because its technology is useful in places where physical fiber connections are impractical. Free space optical technology uses laser light beams to wirelessly transmit data without having to use fiber optic cable. Zev Susia, Chief Growth Officer with X-Lumin, said the company's technology of the technology, it's the same beam of light that goes down a fiber optic cable. The only difference is we shoot over free space. So it's like think of it like a fixed wireless shot, except instead of using RF signals, radio signals, you're using laser light. The beam is transmitted from one optical head and received by another optical head that have line of sight with each other. Technology can be used to hop the beams over long distances without losing any throughput. So you do need that line of sight, and you need that on some wireless shots depending on the spectrum that you're using. Although in this case it's being laser light, it's got to be line of sight. There's no getting around that. The same beam of light moves faster over air than through glass, said Susi, and that's true. I think that's Suisa. The company is hoping to participate in all the activity to deploy fiber across the United States. To that end, Susi was at the recent Mountain Connect conference in Denver, which was heavily attended by people in the fiber industry. There might be a perspective from the industry in general that it's fiber first kind of world, they said. My concern, given the time and cost it takes for fiber infrastructure, is that BEAD funding will not be enough to achieve the mission of broadband for all. If we really want to hit these milestones, we're going to need to look at a mix of technologies. And really, where they're talking about there is more deployments to end user locations that are very hard to reach. Where this can help is getting, again, the backhaul to those areas. So rather than having to run fiber through really difficult areas, you can use this free optics to shoot the lasers through the air. It's not like you can do the same with a fixed wireless backhaul, but this is again using laser and would be supporting higher speeds, I would imagine. He said a powerful use case would be to use free space optical to hop over railroads and rivers. It's taking operators up to a year to get a permit to dig fiber under railroads, and it can cost as much as $25,000 in non-refundable fees just to explore the idea of letting a fiber company dig under the railway, he said. Given the expense and time, it can be a huge benefit to hop right over the rail line without having to sacrifice any throughput. So I guess it all depends on the cost of this. If you could put that's not a very long shot. So if you could put equipment on one end on the other and do that safely, that's another question. If you could do that safely, you can certainly do it at a longer distance. But again, you've got line of sight. A lot of times around railroads, you've got trees and those kinds of things. But if you could just span the railroad, like I he's saying here, you could take care of that problem. He said X-Lumin wants to support middle mile networks as well as backhaul, tower to tower, and tower to data center deployments. At the recent Mountain Connect in Denver, Gary Bolton, who's the CEO of Fiber Broadband Association, said, "I won't argue against free space optics. I think it's a great solution to be able to address a short-term problem, but we're not sending free space optics to any home yet." That's true. Now Google is doing that somewhat. I don't think it's necessarily directly to a home. We'll take a look at that in a minute, but they are using this to provide broadband services to very difficult areas in other countries like India. So we'll take a look at their site in a minute. Suiza said, "It's not really meant as a last mile device to the home. We're not going to put our devices on tops of homes. We have far too much speed and range for that to be necessary. However, if there are very rural areas with a smattering of homes, X-Lumin's technology could bring free space fiber to a nearby point, and then regular fiber optic cables could connect to that point and be deployed directly to the homes." And that makes sense. Again, that would be a backhaul kind of situation where you're getting the broadband backhaul close to where it needs to be, and then you can use fiber to reach those end users. Are there downsides? Any wireless solution can be prone to some interference, but free space optical does much better in that regard than fixed wireless access, according to Suiza. Interference is one of the biggest problems for fixed wireless access, which can be hampered by things such as rain and snow. I think that might be somewhat of an issue for this as well, although I'm not an expert here, but fixed wireless access usually needs clear line of sight to work properly and can be foiled by foliage. Taara, however, has made a name for itself with its fixed wireless technology that runs very complex algorithms to do interference canceling and multipath signaling. Still, though, that is an issue for fixed wireless. I'm sorry, I thought for a minute here this was still a quote from him. He was talking about the free space optics. This is talking about fixed wireless access, which can be hampered by rain and snow. But I think the free space optics also, and at least in the past, had issues with that as well as fog. Something that could be disrupting the light. That maybe they've gotten around that now. He said that fixed wireless access and microwave use a very wide Fresnel zone. That doesn't sound like a real word, does it? Which refers to the width of the signals. Conversely, laser communications use a very narrow beam. In addition, RF is very susceptible to humidity, he said, while laser communications is impervious to humidity. Additionally, X-Lumin has artificial intelligence software that optimizes the laser signal for atmospheric turbulence. So maybe it's not an issue with this. Maybe they also do free space optics with LEDs for shorter distances, so maybe that's where maybe things like fog or rain or snow could be an issue. So he's making it sound like it's not. X-Lumin claims that signals can be used for short-range distances up to a half a mile, mid-range distances up to 10 miles, and long-range systems up to 30 miles, depending on light of sight and the curvature of the Earth. And that's always an issue, is the curvature of Earth when you're shooting something that's got to go in a straight line. They also do, as we'll see in a minute when I go to their website, they do communication up to space, or at least they have that on their website. X-Lumin's pedigree: they were founded in 2019 as a spin-off from company Vision Engineering Solutions, which builds long-range laser systems primarily for government and defense clients. John Strajewski, who had been a co-founder of Vision Engineering, came over to X-Lumin as a co-founder. Although X-Lumin is currently small, with less than 10 employees, it's pursuing opportunities in wireless optical communications, but it's only got a handful of small clients at this point. It's hoping to scale. So these guys are definitely a startup. Suiza said it's only done a friends and family round of funding so far, but expects to announce an institutional round soon. The company's technology is scalable from a commercial perspective because it works with standard telco-grade equipment. We found great performance out of Cisco gear, he said, mentioning Cisco's NCS 540 routers and XR operating system. The company is the only one doing free space optical for telecommunications. Singapore-based Celestial is also using infrared spectrum with hopes to connect underserved people around the world to the internet. And also, as I mentioned, let's first take a look at X-Lumin's site. So this is their website. You can see they've got some bullets here. AI-driven beam correction, turbulence mitigation, 100% emission safe, iSafe laser safety class. That's probably a good idea, I guess, if you're having people install these. You don't want them to get shot in the eye with laser. Precision optical pointing and tracking. Some compliance here. Made in the USA. Optimal. Oh, this is interesting too. So you'll see on their website they've got cybersecurity mentioned as a topic, and they mention here optional quantum key distribution and encryption. So this is using quantum computing and kind of the ability to use quantum states to do encryption. You can also break encryption. If you could do a quantum computer, you could very easily break encryption, but there's also some built-in encryption that you can use with quantum computing. Remote control of signal or network deployments from a signal knock, day and night operations, so it doesn't matter. I wonder if you can see the laser if it's nighttime. Single mode fiber, DWDM, XOS service support, so I see that. And then they've got, again, ground to air and space, and that seems like, with the Defense Department and government, that would have been maybe, again, where they got their launch, so to speak, pardon the pun. So ground to airspace, but then they also have terrestrial point-to-point, and this is what we're talking about here. So they say, future-proof, need 100 gigs today and 12.8 terabits tomorrow, so those are some really fast speeds, obviously. 100% field upgradable, so that's nice. Speed to deployment, establish miles of point-to-point connection in less than 1 day, and that's certainly better than fiber, especially if you've got to go under a lake or a river, or go around it somehow. So no construction delays and zero traffic impact. Nature of X-Lumin's optical systems are fiber in, fiber out, so you can have wireless lit fiber operational faster than fiber in the ground with faster speeds than RF. Never sever, dig never. Unlike fiber cables, laser cannot be cut. So there's, I guess, a tree or a pole or whatever could come down, but wherever they put these things, but you can't cut the fiber. So there's never a worry about digging up segments of street to repair accidentally severed cables. And since Terralink is point-to-point in the air, we are a dig never approach, saving countless hours of excavation, construction, delays, and traffic. So obviously you have to look at the cost of what's it going to cost me to dig, put in fiber, conduit and fiber and all of that versus this equipment and however much it costs to install that. Over the river and through the woods, perfect fiber extension tool for middle mile applications where lakes, rivers, mountains, and RF denied zones get in the way of deployment. Eliminate the need for slant drilling underwater, long-range detours, or right-of-way negotiations and fees. Terralink can easily establish a line-of-sight point-to-point connection over miles of range. Underserved, unserved, and extreme high-cost thresholds. So again, looking at what we have, the challenges with BEAD, serving everybody, and especially those extremely high-cost areas. Some locations present challenges to reach with fiber or RF, whether it's a matter of distance to a core network, inability to dig through granite mountains, or other high-cost challenges. Unlock access to full broadband for all at a lower cost by adding Terralink into your infrastructure design. So again, more for the backhaul and middle mile deployment kinds of things, but that can certainly help in those challenging areas. And as I mentioned, Google or Alphabet, they have been working on this. This is called, it's interesting, they call theirs Terralink. This is called Taara, T-A-A-R-A, fast affordable connectivity using beams of light. And this is part of their X project, which is their, I think they call it their moonshot development area where they do things. This is where they had the Loon balloons, Project Loon, where you had balloons that were going to float over cities and beam internet down, and that became obsolete when Elon Musk started launching satellites. So that I think the technology, the laser technology, I think was something they were working on in conjunction with that. So that kind of morphed into this. But now you can see it's more about getting these. Here you see right here this equipment up on towers. Talks about what they're doing here on their site. So I linked to this. There's a little video here you can watch. When you click on that, it'll open a video. And again, you can see here putting the receivers and the, I guess, transmitters and receivers on a tower right here. And this, I believe, is a video about a deployment they did in India where they're helping to bring internet to some unserved areas. And I think there what they're doing is, it is doing these long shots to be able to bring the internet to the cities. But I believe there also may be some, if I remember when I looked at the video a while ago on this, that it might be a receiver on a building, for example. So go all the way to the building and then deploy it within the building that way. I believe that was the case. So anyway, there's a link to that video there. Talks a little bit about what they're doing here. Provide high bandwidth backhaul, urban last mile extension, bridge challenging terrain, improve network resilience. Here they don't have this. They're not advertising as fast as speeds as 20 gig bidirectional throughput, up to 20 kilometer operating range. Benefits: low environmental impact, low cost of ownership, fast, light, and easy to deploy and redeploy, secure data transmission. So, and here you see technology to kind of automatically aim these things. I guess once you get them pointed in the general direction, somewhat line of sight, then they'll track and find their own perfect location for that. I believe the other technology, it sounded like they had that as well. And there's a little bit of information about their deployments here. So they are Google, Alphabet, X, whatever. Well, it's Project X. It's not X like associated with formerly Twitter, but they call their moonshot kind of development group that works on all kinds of things. Like these are the folks that have been working on autonomous cars, all kinds of stuff. So this is one of the projects in there, and they've got these deployments now that they're doing. So these are out there already. So this is another option for those that want to take a look at this kind of technology. So there you go. So thanks for joining me today. I hope this was interesting. If so, if you would give me a like on the video, I would like that. If you're not subscribed to our channel, click the subscribe button, ring the bell to be notified when I'm live, and I will see you next time for Broadband Deployment News. Take care. Bye-bye.